This section's on solving systems of equations. So we start by solving the following systems of equations by deciding whether we want to use graphing, which works but not great unless you're using a graphing calculator, or by substitution or by elimination. So most students often opt for elimination. If we're going to eliminate a variable, we can choose to eliminate x or we can choose to eliminate y. If we choose to eliminate x, we will multiply the whole equation, both sides, by a -3. If we choose to eliminate y, we multiply both sides of the second equation by a -2. So let's say that we opt to eliminate y. Eliminating y means -2 times each term. And so a -2x and a -4y equals a -10. We will add that equation to the 3x plus 4y, which is equal to 11. And by adding the two equations, we get an x, a 0 pair, and a 1. So we know that x is 1. Then we can substitute that back into our original equation, either equation. If we opt to substitute it into the second equation, 1 plus 2y is equal to 5. Subtracting 1 from both sides, 0 pair, 2y is equal to 4, and dividing by 2, y is 2. So the ordered pair 1, 2 is where these two lines intersect. There are, as you learned from before, there are three possible options that can happen if you have two lines that are being solved. In the first situation, it could be that they intersect in a common point. For example, if we had opted to eliminate the y's, we have a 0 pair by simply adding them together, and 7x is equal to 7 dividing by 7, x is 1. So we know 1 is the x-coordinate of the ordered pair. And when we substitute 1 in, 2 times 1 minus 3y is equal to 7. So a -3y will be subtracting 2 of 5, so y is a -5/3, or -1 2/3, or -1.6 repeating. So that is our intersecting point. You learned last year that your second scenario that can happen is if you decide to eliminate x, for example. We can multiply the whole left side by a -2 and the right side by a -2, and let's make it a +2. So we will get a +2x and a +6y becomes equal to a +10, and adding the two, a 0 pair gets you 0, but 0 does not equal 11. And in that situation, you have two parallel lines that will never cross, so there is no solution. In our third situation, though, we have two lines that are coincident, meaning they are the same line, they're just disguised. If we want to multiply this first line by 4 to get a +1x and a +2y, a -2y, and multiply the right side by 4 as well, we will get a +4. A 0 pair and a 0 pair gets us 0, and -4 and 4 is also a 0 pair, 0 equals 0. This is true. When it's true, we know that there are an infinite number of solutions because they are the same line. So the cases are still true. A single solution, no solution, or an infinite number of solutions. So if we're going to solve this by a system of equation method, this is the twist for pre-calculus. If we look, we have a typical line like we've had in the past, but now we're trying to figure out where that line is going to intersect something that's quadratic. Looks a little disguised, but it's a quadratic in nature. So since we have an x squared term and an x term along with the negative y term, if we add these two equations up, we can eliminate the y's. We could also solve this equation for y and substitute it in. So adding these two equations together, there is nothing to add to the x squared, but a positive x and a positive 6x gives us a total of 7x. Positive y and negative y eliminate, and we will be left with the other side of the equation that has a negative 5 and a negative 5 for a negative 10 total. When you have a quadratic with a squared term and a non-squared term and a constant, we need to bring everybody to one side. So we're adding 10 to both sides, and now it's equal to 0. We ask ourselves what are factors of x squared, which will be x, and what are factors of 10 that add to become a 7, and that would be a positive 5 and a positive 2. So we know that these two, this parabola and this line, are going to intersect when x is a negative 5 and when x is a negative 2. So we write our ordered pairs out as a negative 5 with some y coordinate and a negative 2 with some y coordinate. We can substitute our x back in, or it might be more efficient to solve this top equation for y and say y is equal to a negative x minus 5. When we substitute a negative 5 in, the opposite of a negative 5 minus 5 is 5, a positive 5 minus 5, which is 0. So negative 5 substituted in gave us a 0 for y. If we substitute a negative 2 in, negative 2 minus 5, or the opposite of negative 2 minus 5 is a positive 2 minus 5, and so y becomes a negative 3. So we believe that this line and this parabola will intersect at negative 5, 0 and negative 2, negative 3. So negative 5, 0 and negative 2, negative 3 are our intersecting points. Let's verify this by graphing. To verify it, we will graph our line, which is y equals negative x minus 5. So it crosses the y-axis at negative 5 and has a negative slope, meaning falling 1, running 1, or rising 1, running 1. Well, that's good. We can see one of the points where we are intersecting and a second one. So here is our line. And now we need to find the equation for our parabola. So if we bring the y to the opposite side by adding a 0 pair, we will get x squared plus 6x is equal to a positive y minus 5. And then to complete the square, we ask ourselves what is half of the middle term squared. Half of b is 3. 3 squared is 9. If I add 9 to the left side, I have to add 9 to the right side. And that gives us an x plus 3 times an x plus 3, or an x plus 3 squared. And y minus 5 plus 9 is y plus 4. So when we subtract 4 from both sides, x plus 3 squared minus 4 is equal to y. Our vertex moved 3 to the left and 4 down and had no vertical stretch, and it's not reflected. 3 to the left, 4 down puts the vertex here. And then if we move 1 to the right, 1 squared is 1. 1 to the left, 1 squared is 1. 2 to the right would be up 4. 2 squared is 4. 2 to the left, 4. And lo and behold, here's our parabola. And these are the 2 points of intersection. Extra example, what if we were asked to solve a linear equation once again? Y equals negative 3x minus 5 if I subtract 3x from both sides, and an x squared plus y squared equals 25. X squared plus y squared equals 25 is not quadratic because both terms are squared. It's a circle. So we're going to intersect a circle with a line. So one of the ways to do that is to solve your equation for y, your linear equation for y, and then substitute your negative 3x minus 5 in for the y value of your y squared term. So x squared plus this negative 3x minus 5 squared is now equal to 25. X squared plus, be careful, negative 3x minus 5 times negative 3x minus 5, squaring it, means that we need to FOIL it out or double distribute, because it's not simply a positive 9x squared plus 25. You lose your middle term. Negative 5 times a negative 3x is a positive 15x, and a negative 3x times a negative 5 is another positive 15x, so you would lose your positive 30x. So combining like terms, x squared plus 9x squared is 10x squared. We have a 30x and 25 on each side, so if we subtract 25 from each side, we get a 0. When I see two terms each with an x in common, I'm going to factor the greatest common factor out. 10 times x times this x plus 3 is equal to 0. Our first term can be equal to 0, and our second term can be equal to 0. So our ordered pairs start with 0 for the x term and negative 3 for the x term, and we have to figure out what y is. A great place to plug that in is this linear equation. Y equals negative 3 times 0 minus 5, so when x was 0, y is a negative 5, and y equals negative 3 times negative 3 minus 5. 9 minus 5 is 4. So our line and our circle should intersect at 0, negative 5, and negative 3, positive 4. Let's check. If I graph the circle, a circle x squared plus y squared equals 25 is a circle with a radius of 5, centered at 0, 0. Oh, there's one of our points. Forgive me for not drawing a great circle here. And then y equals negative x minus 5 is a line that has a slope of a negative 3 going through negative 5. So on the y-axis, so we're going to rise 3 and go left 1, rise 3 and go left 1, rise 3 and go left 1. And when we draw this line, it should go through our ordered pair of negative 3, 4. And finally, we have a cleaner who needs 40 ounces of a cleaning solution, and it needs to be 11.5% acidity. So the solution is mixed from 3 jugs. Those 3 jugs are 30%, 6%, and 5% acidity. We want to know how much from each jug should be mixed in order to obtain that 40 ounces of 11.5% acidity. So when you go to buy vinegar to clean your house, one jug that you can buy is distilled vinegar. Distilled vinegar is actually cooking vinegar. It's what you would use to can food. It is 5% acidity. Cleaning vinegar is 20% more powerful, more acidic. It's 6% vinegar. But you can buy up to 30% acidic vinegar in your home improvement stores. So if you want to mix a concoction that's going to allow you to clean lime and other things from your surfaces, You can use a spray bottle with the vinegar and some dish soap. So to see how this works, apologies, I'm drawing when I want to move. We're going to set up this equation but not solve it. So a cleaner needs 40 ounces of the 11.5% acidity. We have 3 different kinds of vinegar. One type is 30% acidic, a second is 6% acidic, and 5% for the third. So x plus y plus z have to add up to 40 ounces. The percentage concentration of the acidity, 30% or 30 hundredths x, plus 6% y, plus 5% z, should add up to 11.5% times 40. Amount plus amount plus amount equals amount. Percent times amount plus percent times amount plus percent times amount equals percent times amount. My example, if you have my notes sheet, should say something of the nature that we want to use a certain number of ounces that are one particular one. I don't remember what it is off the top of my head, so we aren't able to solve this. This has 3 equations with 3 unknowns, 2 equations with 3 unknowns, therefore it can't be solved at the moment. But it's a good practice to set it up. So your assignment today is to work on the 7.1, 7.2 linear and nonlinear systems.